In this video, we're going to be talking about the scale of manufacture of a product and how that could change whether you're aiming to manufacture one product or whether you're aiming to manufacture 10 million. The design choices and the manufacturing choices you make will change. As a general rule of thumb, you can say that low volume manufacture products, maybe you're making one, maybe you're making 3, 10, the cost per item is often quite high because you're not going to use specialist tools to help the manufacturing process. Now, specialist tools can cost a lot of money and can take a lot of time to generate. So if you're going to make a small batch of components, you often don't use specialist tools. Instead, you'll use general tools that will then utilize an operator's skill to create and manufacture the parts that you want. That process is often quicker and cheaper if you do not have any specialist tools. However, if you were going to make a high volume manufacture of a product, let's say you were going to make 10 million, let's say you were going to make 1,000, the chances are that you'll want to implement some specialist tools to help speed up your manufacturing process. So the cost per item can become lower. However, you'll need to implement these specialist tools, which will ultimately make the cost go up. What do we consider as a specialist tool? Well, a specialist tool is something that is programmed or made specifically for the task in hand. So it could be a case of writing a CNC machining program, whether that's for a CNC lathe, mill, laser cutting program. Those take time and effort to generate. They're quite general tools, however, you've still got to take the time and effort to program them. Once they're programmed, they can be replicated quickly. Other things such as mold tools for an injection mold can cost many thousands of pounds to get the mold tool. Once you've got it, you can really quickly and really cheaply make lots of components. So a lot of your cost then is in the tooling rather than in the individual product being made. Other things, jigs and fixtures, setting up a whole production line, implementing some form of robotics into your systems, an automated system. So you may have an automated production line from taking in a raw piece of material, taking it through a CNC machining setup, putting it into another machinery that's doing a finishing or deburring process, and then automating that out into a export box. That can also be set up, and that is set up quite regularly, but these systems cost a lot of money. Then if you're going into something really high tech, we're talking about mass manufacture of cars. So BMW, Tesla have entire factories that are just specifically built to handle one type of car. Now in China last year, Tesla set up a whole factory system that 80% of the work was automated purely to make their Model 3 sedan purely for the Chinese market. It cost them hundreds of millions of dollars, but they've projected that over the lifespan of that car, looking at the quantities they expect to sell and the profits they expect to make off each one, that money will at some point cross over from being an expenditure into being pure profit for the company. So we can say then that as the volume of parts increases, it becomes more viable to use specialist tooling, which costs lots of money, to increase the speed, the quality of each part, but it reduces the cost per item. If the volume of a part is low, then the specific tooling cost will often be too high and be more generalized manufacturing, and a more generalized manufacturing process should be used to keep the costing down. So a one-off product, what is a one-off product? Well, often it can be large infrastructure projects, ships, oil rigs, houses, factories. You're going to make one of them. Every individual house that's made is individual. Every factory that's made is individual. Yes, some people now try and make them into production parts. So for a factory, for a steel clad factory, a lot of the components now can become mass manufactured parts, but a lot of the time they're still very customized. So we also have then small products, small production run products, customized parts. So having something completely customized for you, having a prototype, even the jigs and the molds that we were talking about that are specialist tools, you would often only make them once, so they can also be considered as small scale products. The manufacture of one-off parts is often uses very little automation, because automation takes time and effort to set up. And again, specialist tooling is the same. So we look at using the worker's skill to produce these items. Now, if you've ever seen any how it's made videos where they're creating prototypes of cars, you can see there's often a small team of people that are going to manufacture the whole of that prototype from start to finish. With these low quantity parts, the cost per item is high because there's a lot of time and effort from the skilled workers that has to go in. It's not a repeatable process. So here's a little example. So here we've got a little plastic lamp. Okay, it's just something I've pulled off the internet. So there's two different ways here of making this lamp. So one would be to use a lamp, make the lamp using a 3D printer, and the other one would be to produce an injection molding process to make the lamp. Now I've done a little costing for you. So if we go back to the 3D printer, we've got design costs at £200. That's our initial design cost. That's the same for both. It's a one-off cost and it's not likely to change. The next one down is the manufacturing setup cost. So this will be, again, a one-off cost per batch, and we'll talk about batches in a moment. But a manufacturing setup cost is how much money is it going to cost me to get my machinery and my processes ready to go. So if we jump back over to the injection mold, first we have to pay for an injection molding tooling to make our lamp. In this case, I've just estimated a cost at £3,000. It's likely to be much more. That's a one-off cost. Once you've got it, you've got it. Then we've got a manufacturing setup cost. So this is going to take a bit more time and a bit more effort to set up our injection molding tooling. We're going to have to play around with the temperatures. We're going to have to make sure the settings are correct. We're going to have to do a couple of test prints just to see if it works. So that's a cost per batch. So if we go back over to our 3D printer, our 3D printer running costs I've put down as £8, raw material costs as £2, and then a cleaning and finishing cost of £8. So if we look down here, if we're making one of these using a 3D printer and we were implementing the design costs in, we would be looking at £223 each. Now if we go over to our injection mold, the injection mold running cost is a lot less because it's a quicker process than the 3D printing, so that's only going to cost us £1. And again, material cost, there's less material. It's a different type of material, so we buy it in a raw format, whereas the 3D printer raw material costs are going to come on a spool. So we're adding a process for that plastic, which is going to increase the cost. So I've then got the same cleaning process for our injection molding. However, because the injection mold comes out better, the cleaning and finishing costs are much lower. However, for one part, the cost, if you include all of the costs above, is £3,277, which is a huge amount more. However, let's project this across 10 parts now. So if we've got 10 parts, now remember, the design costs are only once, the manufacturing setup cost is per batch, and we're just going to assume this is one batch just to keep it easy. So those two don't change. So each part cost, we're now adding this £18. So for 10 parts, it's the design cost plus the manufacturing setup cost plus £18 times 10, and then I've divided that by 10, and that equals £39 each, which is a massive difference between making one. Now then, if I project that across 10,000 parts, the cost comes out to £18 each. Now if we go back over to our injection mould, where our initial cost was £3,277, for 10 parts, they're still £328 each, because we're trying to absorb this £3,000 cost. However, when we jump up to £10,000, the cost is only £3 each, and that is because the running cost, the material cost, and the cleaning cost are much lower. So, just a little side note on this little lamp at the top here, have a guess of its value. Right, you can buy this little lamp for cool, oh, my pound sign's not very good, £300 for a lamp. So actually, we're going to make a nice profit. On the previous slide, I introduced something called batch volume. Now here, I'm just going to talk about this a little bit more. So a small batch volume will be a small volume of parts, could be 2, 4, 10, 100, that are made at one time. However, you may make many batches running over many years. So we may make 4 this week, we may make 4 next week, we may make 4 every week for the next 2 years. The benefits of this are that the one-off costs for tooling can be absorbed slowly, and the more you produce, the cheaper all of the parts become. You can make and store low volumes of stock. So let's look at this part here. We may make this part in batches of 4. We've always got 4 in stock, so if we know we've got a steady trickle of parts going out the door, we know every week we're going to produce 4 more, we're going to produce 4 more. So that will keep our stock volumes quite low. Now the benefit of that is that the stock volume, you have to pay for the materials, and you have to pay for somewhere to hold it. So when you do complex, fully inclusive business costings on parts, those things become very important. A disadvantage of doing small batches is that the setup costs for each batch will be higher, because we have to take time to fit and test and perfect. If it's an injection molding tool, we have to get that in the machine, we have to set it up, make sure it's all right, maybe do a test part, check the test part, make sure everything's okay with it, run it through some more quality processes, and then we'll be ready to manufacture. Lots of small and medium engineering companies utilize this method, not necessarily making 3 or 4, but often making tens, hundreds, sometimes thousands, and it depends what the products are, what you would deem a small batch. So the opposite side of that is a large batch. So more parts will be made in a batch than a small volume batch, and this reduces the setup time. So if the setup time is going to cost us £60, when we're doing a small batch, that £60 has to be absorbed into that batch. Now it makes sense that if we're going to make a larger batch of components, that £60 across that batch is going to be less. Therefore, the cost per part comes down. However, the disadvantage of this is you may end up with many parts in stock, more materials, more work at a time, more storage space being taken up for parts that you're not going to sell immediately. problems then can become, what if you change the design of your part because of a fault? You may have 10,000 sat in stock that you've had to pay to make, you've had to pay for the materials, and you've paid to store them, suddenly become redundant. So having a balance is very important. So here's a little chart which you'll see all across the internet. So down across the x-axis here, we've got items per batch. Up the vertical axis here, we've got cost. So we can see here, so the holding cost. So the more items we produce, the more it costs us to keep hold of these parts. The transaction cost is the actual build cost. So low volume is going to cost a lot of money. The more we make, we're absorbing the costs here, and we're going to eventually get to a point across here where the transaction cost, the actual making costs, are as low as they can be. So what is the optimum batch size? Well, we can calculate a curve through a little bit of math, and we can work out exactly what the optimum point is to absorb cost, absorb the holding cost, and absorb the actual manufacture cost, and you can come up with an optimum batch size. We don't need to go into all the maths of that, so we're just going to leave that there. However, this is a nice graph just to remind you, the more you make of something, the less it will cost to make them. However, you have to incorporate the cost of the raw materials, the time to make them, and the holding cost, so the storage cost, into that as well. So it's not always a case of let's build 1 million of these parts and we'll slowly sell them over a couple of years. That will actually cost your business lots and lots of money. So moving on, just going to talk a little bit about mass production. So mass production is where we're looking at very large numbers of identical or very similar products being produced, usually on a form of production line. Now on a production line, you will have workers or stations, it could be automated, that do a specific job, and then it's passed on to the next part of the production line. It does its specific job, it's passed on to the next part of the production line. So you continuously have a stream of parts going through this production line. Now this is a very, very good cost-effective way of manufacturing parts, especially big assemblies. It was actually the invention that the production line got invented by Henry Ford, who had the Ford cars back in the early 1900s, and it was that manufacturing process that enabled the cars that he was making to become much more cost effective. Then they're more appealing for people buying them, which means that they started to sell more and more and more until we've got this big car industry that we have today. So production line machinery is often very specialized, and it's designed to do a certain function on a certain product. The cost can be very effective, but it is difficult to make changes into that production line. So let's say you had a production line for making, I don't know, Series 1 BMWs. So you know for 2 or 3 years, all of those Series 1 BMWs are going to be the same. They may have different color coatings, they may have some optional extras that are changed, but pretty much the car is going to be the same. If after 3 years' time they redesign it and some of the features change, the engine changes, that whole production line will then need updating. The problem with that is that they won't be able to manufacture any of the old ones, and there's another huge cost to be implemented. They may need to pay for lots and lots of new machinery. Finally, we're going to talk about continuous production. So this is often used in the chemical, petrochemical and raw materials production. It's also used in food and beverage and household consumables such as cleaning materials, toilet rolls, fabrics, It could be other consumables that we're using engineering, nuts, bolts, screws, washers, batteries. So continuous production often uses very specialized equipment and automation processes. It removes as much human interaction as it can, allowing for a 24-hour continuous production run to go, which will keep the costs as low as possible. Yes, it costs many millions of pounds to set up, but if you have a process then that can continually keep going and going and going without having holidays, without needing a toilet break, then you're going to manufacture your parts as many as you can, as quickly as you can, and the product cost coming out of the door is going to be as low as possible. Okay, on the next couple of slides are some videos. Please take your time to have a look at them because they will be very useful and you can see some of these in process. In summary then, having an understanding of the likely volume of parts that you'll be required to design to produce from your designs will often change the manufacturing processes and can change how you go about thinking about the design of your products. So remember then, if you've got one-off or very small production, then you're going to be depending on workers' skills, and they're going to be using machines that are quite generalized and that can do lots of different things. If you've got higher batch products, you're likely to be considering specialist tools to help speed up the manufacturing process. So if we're making things out of plastic, we may be then looking at injection molding tools, for example. And then finally, if we're going to be mass producing parts, or we're going to have continuous production, you're going to have to think about how your parts can be designed with having very little human interaction, processes that can be repeatable over and over and over.